I'm Matt Godbolt.
And I'm Ben Rady.
And this is Two's Complement, a programming podcast. Hey Ben.
Hi Matt.
How's it going?
Good.
So it's that time of the week again, and you and I are staring at each other through webcams and blurry backdrops and all of that. How much processing time do you think is being wasted by GPUs blurring backgrounds or substituting in other people's backgrounds right now? I mean, there's got to be a substantial amount of heat death of the universe is caused by Google Meet and Zoom and all these things, like doing this really intense AI operation to determine what is foreground, what is background, and then doing something with the background.
Yeah. Well, now that crypto's crashed, we got to do something with all those GPUs. So might as well be this.
Very good point. So we're staring at each other. We're staring. We're staring at each other. It's that time. And this week, I figured we've been talking on and off about various different languages and our experiences with them. Obviously, Python, JavaScript, C++, HTML, such as that's a language. It ends in an L, so it's a language, right?
The L does stand for language.
It's like SQL, right? SQL, structured query language.
True.
It's not really that structured. You can do more than query with it, and so questionably a language. Visual Source Safe, again, none of those words are true.
None of the above.
Anyway, I feel like, we're off target already. But talking in general about languages, and the one we haven't really spoken about is Rust. Mainly because you and I haven't got as much experience with it as perhaps we ought to in order to have like really strong opinions, but we have used it. Yes. I've used it on a couple of projects. I've got a toy project that I created, which is like my standard way of learning a new language, which is to write a ray tracer or a path tracer in it, and that was a lot of fun, and it's pretty performant. I was very impressed with it. That was a while ago, and then I've written some command line tools in it since, and you've done some work on it too, right?
Yes. Yeah. I made some changes to the Ethereum node software that was written in Rust. To do a little bit of research into how the Ethereum network worked. And this was 3 years ago. And I have basically forgotten everything about that project. I probably remember a few interesting things to know and tell. But my intent, what I was trying to do there, and what I think reasonably accomplished there, is to sort of draw out a map of what the Ethereum network looked like, not necessarily from a geographic level, but more like what nodes are actually producing the blocks that wind up in the blockchain, and how do those blocks propagate across the blockchain? Because at the time, I was really interested in prediction markets. Augur was one in particular that was had a lot of attention and was people were talking about on Ethereum, and I was like, well, I mean, knowing what I know about traditional financial markets, if someone's going to place an order and it's going to take some amount of time to get to the exchange where it's going to actually be recorded, being able to know that order is coming has a lot of value. And that is actually
this is talking about like in a distributed exchange, like you would see on an Ethereum-y magical something. Got it. I see.
Yes. So I was trying to figure out if this was a problem. Basically, is this a flaw in the theory behind distributed? I mean, it would really be any distributed type of exchange. Yeah. But specifically, I was interested in prediction markets and Augur in particular.
What is a prediction market? I feel like we're getting derailed immediately here.
Yeah, right.
You should tell me what a prediction market is, because
we're going to put a lot of things on the conversation stack, and then we're going to pop them back off again and figure out
and then we'll be like
started. Yes,
blurry backgrounds.
Blurry backgrounds. A prediction market is a particular type of financial exchange. It's similar to a futures market. It's similar to, if you know what a binary option is, it has some similarity to that. But basically, the idea behind a prediction market is that you use the quote-unquote wisdom of the crowds to predict the probability of future events by letting people bet on whether those future events will occur. There have been a few of these sort of normal centralized ones. I think there was one called, sort of with an I, Insight. I want to say Insight. I don't know if that's correct.
It rings a vague bell that like some university was involved with one of them at some stage in order
to... Well, there's one called Predict It,
right.
which actually recently I think got shut down. They had gotten a letter, a no action letter from some government agency, the CFTC,
the SEC or the FTC, or
something like that.
CLC or.
Yeah, and that agency recently rescinded their no action letter because of some things that Predict It was doing. And by the way, when that happened, I'm sure all of the Augur and sort of Ethereum-based distributed network prediction market folks went, see, I told you so, see.
Right. Right.
Yeah.
So this prediction market is somewhere where I can bet on a future thing happening or not. Mm-hmm. So
yes.
like a presidential election or something like that, and I say I think the Conservatives are going to get in to the next UK general election, and so I bet, but who's taking the other side of the bet, and how does someone work out the probability of that happening or something? Because presumably I bet 100 quid or whatever, and then someone will how does that bit work?
Yeah, so I mean the way that different markets do it in different ways. My memory of Augur is that the way that they did it is that you basically wound up creating 2 tokens every time you sort of placed an order. There was one that it would happen and one that it wouldn't. And if the transaction got through, or basically if the order was filled, if you matched with somebody else that took an opposing position at a matching probability and price, like that's sort of the magic of prediction markets, is that the price and the probability are the same.
They're linked together in some way, right?
Exactly. Right. So like, in the case of Predict It, it was like all of the prices have to be between 1 penny and 99 cents, right? And that was basically the probability that you were saying, if you're buying something for 56 cents, you were saying there was a 56% chance it was going to
And something
happen.
Like you buy it for 56 cents and it's either worth nothing or it's worth $1 when the market when you decide, and therefore the price approaches the certainty of the event as it comes. Yeah, got it. Okay, now that makes sense to me as some sort of very hand-waving level.
Yeah.
But so any exchange, from a traditional finance point of view, like you say, any exchange, knowledge is power, and if you can see somebody is strongly buying up something on one side of your network, and you can see that the price is therefore going to go up, you can take advantage of that. And that's what you were trying to do with this, was to say, is that a problem?
Yes.
Can this actually be gamed in some way, or is it just fundamentally flawed? And in order to do that, we're going slowly back up the stack here, although I can easily go back down.
We're going to get to Rust here any minute.
Any second.
Yeah, right.
You wrote a program in Rust that parsed some kind of exhaust from the Ethereum network itself to see how information traveled across the network.
Yeah, I mean, I wouldn't even give myself the credit to say that I wrote a program in Rust. What I did was I made some modifications to the Rust Ethereum, the Ethereum node that was written in Rust, to capture some information as it was flowing through the node and to sort of intention and change its behavior a little bit. Basically, what I would do is when an Ethereum node connects to the network, it finds some number of peers that it can pull information from, basically pull the blockchain information from. And I made some modifications to that to actually actively seek out peers in the network. So you, instead of just taking whatever peers I discovered, I would try to backtrack and figure out okay, well, you got this from this node, so I'm going to go back to that node and connect into it directly and figure out, oh, you got this from that node, and sort of try to work my way back to be where are these blocks coming from, right? What nodes are generally originating the blocks on the blockchain, because that is probably the first reliable place that you would see this information. Additionally, the other thing that you can do when you connect to these nodes is look at the transaction pool. So these are the pending transactions that may or may not show up in future blocks.
I see.
And
these
you
are
can
like
get
to be mined in the kind of
Yes.
Bitcoin-y sense of it. There are things that are yet to be checked to make sure that they are actually okay in terms of the
Right.
rules of the network, but they will be put into the next available block once whoever wins the lottery and
Right.
publishes a new one. Got it.
Exactly. And you can see, the gas costs that they're willing to pay, and the way Ethereum works is the higher you pay, the more you pay for your transaction costs, your gas costs, the more likely it is that you'll wind up in a block. So you can look at it's almost like being able to look at the queue of incoming orders into an exchange. Like these orders haven't hit the book yet, but they will at some point.
Assuming they aren't assuming they aren't ill-formed or they haven't got that double spend kind of things. That's the whole thing that the blockchain and technology. The thing that the miners are supposed to be doing is doing all these checks.
Right.
Then that will stand. That order will stand once all of the checks have been done. So you can look at it and kind of go, well, this is an intention to send an order, even if it isn't an actual order, and you can use that as that's really interesting.
Right. And you can even do some things to validate for yourself that those things will, in fact, clear through.
Because you could be mining yourself at this point. You could, your node is capable of doing the mining. It's just that you need to solve some drastically complicated maths problem in order to mine the block, and that's just not what you're interested in doing. But you could run the same checks that you would do.
Yeah. You don't even need to solve the drastically complicated math problem.
Right, because you don't care about that part of it, right? You don't have to sign
it
effectively, which is
Yeah.
Okay. And
So,
that happened to be written in Rust already, so you modified an
Yes.
existing piece of code.
Yes.
So what were your experiences like then? Obviously, you've done a whole bunch of procedural style, sort of C-derived-ish languages before.
Yeah.
What were your thoughts about Rust then?
Yeah. Probably the closest analog to Rust that I had worked with at the time, and this is probably still true, is Scala. I wrote a little bit of Scala.
Interesting.
Probably about 10 years ago, something like that. That had, that sort of heavy use of algebraic types and pattern matching and all those sorts of things.
Got it. Yep.
And, it was a little hard for me to separate the challenges of working in that style of language versus the challenges of just working in a completely unfamiliar code base, right? Because this was a fairly mature piece of software, and I kind of knew the domain, but not nearly as well as I sort of had to eventually learn to sort of figure all this stuff out. So there was a lot of additional layers of challenge heaped up on top of this to sort of get me to where I wanted to go. But the language itself, I thought, was really nice. The tooling, I thought, was really nice.
Right. Yeah.
The compiler was a little slow, but it was also doing a lot of work for me. So it was sort of like, okay, I get why this is going to be slow. The interesting thing for me, obviously being so test-driven and everything, was I tried to write some tests for the code that I was changing, and I managed to write a few, but the code in this Ethereum wallet, I don't think was particularly designed to be tested, and even if it,
it's not doing anything important after all.
Right, of course, only sending transactions worth hundreds of millions of dollars. So yeah, the challenge, I think, was finding a new level for me, a new sort of baseline for me in the balance between sort of types and tests, right? Because depending on the language that I'm working in, I might write more or less tests. I definitely don't want to write tests for things that are guaranteed by the type system. That's silly.
Right.
And so working in Rust for me was sort of, I was discovering multiple things at the same time. A, how this Ethereum node worked. B, the general structure of this code base. C, how Rust worked. And then D, how to write tests for existing code in Rust that didn't just check what the compiler was checking for me.
Got it.
So all of those things together made for a pretty interesting but challenging experience.
But so what was the, just ignoring the Rust aspect of this for a second, what was the upshot? Did you find anything interesting in your analysis?
Yeah, I'd have to go back and look at the data that I captured to remind myself exactly what it was. But what I saw was that there at the time, it's probably different now, there were very specific nodes on the Ethereum network where it's like if you wanted to see the transactions first, you just go there and you get them.
And these are like nodes where the whole thing's peer-to-peer, right? So if I want to put a new thing on the network, I connect to just some random peers, but clearly the folks who are placing orders more are either geographically located in a place where their client had connected to them to some set of peers that were able to take the load or some other aspect. And you were able to say, well, these are where you should go if you want to see those kinds of orders and whatever reason.
Right. I didn't come to any conclusions about the reason, and at the end of the day, it's not really that important. Like, is this happening because of internet network topology? Is it happening because of geography? Is it happening because of default settings in the
is it just literally
the nodes? It's like
connection.ini file in there.
Right. But it doesn't actually matter if the transactions show up somewhere first.
That's where you want to be
there first, right? Yeah. So that actually discouraged me from pursuing any more stuff with distributed prediction markets on Ethereum, because I was like, well, I think this game is the game you're playing here is not, how do I operate effectively in this market? The game you're playing here is how do I get the transactions first and literally front run. I mean, people use the term front running for lots of things,
which is a legally defined term. I would just like to say, because people use it in a lot of ways that are not correct, especially given our industry. We're a little sensitive to that. But in this case, literal front running, because you could observe the pending orders that were yet to be placed on the blockchain, and you could make a decision based on them, and then you could try and get your order in before them by sending it to faster nodes or different nodes or more or something.
Pay more gas. You could send it to the exact same node. You say, okay, they're paying 2 ETH of gas. I'm going to pay 3 ETH, and I'll get there first.
Yeah, that makes sense. So gosh.
Yeah, so that really dissuaded me from doing anything in those markets, because I'm like, this is very gameable. And that was basically my conclusion. And then after that, I just stopped working on all the Rust. I kind of like, it's almost like you have the revelation and you're like, oh, and you just sort of like back away slowly. And that was it.
Yeah, well, so a lot of Rust there, but there was a lot of other things going on for you. Yeah. So my toy project was, at least the first one I wrote was this path tracer or ray tracer. I mean, they're similar. Path tracing is what it's doing technically, but ray tracing, if people know what ray tracing is, it's basically that. And I do that. I've done that in pretty much every language I've learned of recent times. It's just like my kind of icebreaker. I know the domain fairly well. The maths is pretty interesting. There's some modeling things. It's kind of an OOE type project, but you don't have to do it in OO. In fact, I have a talk where I write that program 3 different ways in C++ using object-oriented or functional or data-oriented design kind of techniques, just to show that they're how multi-paradigm C++ is. But anyway, I was writing this in Rust. I'm very familiar with it also. It's almost like the opposite of your problem. I wasn't exploring anything other than the language. And my experiences were very positive. I also, and this was a little while ago, I also hit the compiler is slow issue, but then I know that it has improved a lot since when I was writing this particular bit of code with. And I was able to crack out something that I was pretty happy with. And then where I fell over was trying to get it working nicely with multi-threading. And maybe that was just my inability to express to the compiler that what I was doing was, quote, okay. Because I couldn't convince at the time the borrow checker, the way that I was sharing sharing constant state and had some things that were mutable that had locks around them. I couldn't explain it to it that like, hey, I've got 8 threads here and they're all doing different parts of the picture. So you don't have to worry about them treading on each other's toes, I promise you. Again, either maybe I was mistaken and I was actually doing something that wasn't safe and it was just, but, or you couldn't explain it at the time, or I just didn't know how to do it. But certainly I ended up writing unsafe around just one tiny bit of the code. And that's, again, somebody could probably go and find it on GitHub and tell me what I was doing wrong. But that kind of was like a reminder that there is an escape hatch in Rust for things. And, on the one hand, I was disappointed. I think at the time I was like, oh, gosh, this is silly. Can't do any non-trivial program without invoking, unsafe stuff, which turns off all of the things that Rust guarantees you, which we should actually talk about, because obviously if people are listening here, just hearing us talk about Rust, the things that Rust can do for you is pretty clever, the compiler. But it occurs to me on sober reflection that all of C++ has the unsafe keyword right at the very beginning. That's like the first thing you open. Void main unsafe is what C++ is. And so kind of anything that restricts the scope of the unsafety to smaller and smaller parts of your code has got to be a good thing.
Yeah.
But I think probably that is just something I've learned to carry around with me. And then I trust myself, rightly or wrongly, not to write code that is unsafe inherently, even though there's no protection in C++ from you doing it. You can easily do the wrong thing all of the time. And that's why I turned on all the warnings, I have all the sanitizers, all of these things to try and give me a safe mode light. But Rust has it kind of as the default, which is like a huge, huge, huge boon to Rust. And so one of the things that Rust has is the borrow checker. And this is like a technology relatively novel to my knowledge. I don't know where it came from. Maybe a research that was done just for the Rust language. But it is a way for the compiler to track in the type system the kinds of references that objects have. And so you can pass an object to some other function by reference, and the contract there is that the lifetime of the object from the parser to the parsee, the lifetime of the caller effectively has to be longer than the lifetime of the callee, right? The callee can't hang on to it, unlike, say, in C++, where you could just go, oh, thank you for passing a pointer to me. I'm going to store it in a member variable now inside my class. Like, that would be an error in Rust, because it's like, no. I can't prove now that you aren't going to live longer than the person who called you. So you can't do that. And there are ways and means of explaining when it's okay. One of the ways it's okay is like, actually, I'm not passing you the value. I'm not giving you a copy of a reference to the value. I am giving you the ownership of that value. It's yours now. I can't see it anymore. I can't use it anymore. And now you have it. And now, again, that's fine. That's safe there. The lifetime now lives with you. And I can't see it anymore. That's great. And then there are all sorts of ways of dealing with mutability and non-mutability. So you can pass multiple references to multiple objects for an object that are read-only. If the compiler can prove that the caller, again, has a longer lifespan than all of the things that it's passed to. But you can only pass out one mutable reference and you can't have any read-only references at that point. So kind of a bit like, I suppose, like locking. You've got optimistic read locking. Everyone gets a read lock, but the writer's lock requires all the readers to go away, and then you are uniquely the person with the reference to that object. And that's done, again, in the type system, which is really, really clever, because it means that there's a category of bug that you just can't write. You can't express it. Exactly as you were saying with the tests that you were writing. Any test that says, is the lifetime of this object okay, is moot because it just won't compile if it's not right.
Yes, exactly.
And that's amazing and powerful, but because programs are complicated and obviously it is in general impossible to determine the flow of a program statically, there are limitations of what the borrow checker can do in code. And that also takes a while. It's part of the reason that the compilation process is a little slower, is it's got to do this kind of tracking. So that's my experiences with Rust, was trying to explain to the borrow checker what I was doing was okay. And then more recently, I wrote a little command line tool to replace like 25 lines of Python, and it was about 25 lines of Rust. And it just worked, and it was really easy. I found it quite like the command line parsing library was there and easy. And we should say, Rust has an amazing community of libraries that are easy to install using Cargo, which is like the one size fits all executable that is like build the code, download the dependencies, package the code, send the code up to be shared. It's just great, and it does everything the right way by my own personal biases of how things should be done.
Yeah.
So, that was a really good experience writing a little command line tool. And as a pleasant surprise to me, almost everything that is built by default is statically bundled into the executable, the resulting executable. So as long as you have a somewhat contemporary libc and a couple of other like very core libraries that you're likely to have on your system, you can pretty much just copy that executable around. And that was exactly the use case that we had. Was to be able to give people a little, small binary that they can just run and get a simple output. It was just like a log parser, and that was great. Yeah. So that was a great experience. I like that.
Yeah, I dig that model a lot. I mean, that's part of the reason I think we've talked before on the podcast about like I've never taught myself Go because I feel like someone should pay me to do it because it's just so useful for that category of problem that I just know at some point in the future I'm gonna have to do that, and I'm just like I'll do that on the clock.
Yeah. Go was the sweet spot for me before.
Yeah.
And then actually, so recently I hit an issue where I had, in fact, people can't see this obviously on the podcast, but behind me I have a little scrolly device. It's like a physical device I plug in, and it has 64 by 32 LEDs or something like that, maybe a bit more than that. And I can put arbitrary scrolling pictures on there, and it just literally, they're animating GIFs I can post to a web server, and it ends up on there. And so I have like stats and things like that appear on it. And it's great. It's fun. It's called a Tidbit. There, you can still buy them, but they're more expensive than you think. But anyway, the little program that you can run to like write a little script to push particular images to it that provides, like here's a framework for doing scroll texts and wipes and all that kind of stuff. It's written in Go. And so it's just a binary. They say, hey, yeah, just download this binary. And so you do, and you get it, and that's great. And I'm, in my mind, Go binaries are just statical, God. Go binaries are just static executables you run, and they just work everywhere, right? As long as you're on the right architecture and roughly the right operating system, you're great. But this was not true. For this particular thing, it was linking with like libwebp, which is the logical successor to animating GIFs, is the WebP format. And that was dynamically loaded. It just so happened that I had it on my system, so it worked. But I upgraded my operating system, and it no longer worked. And I actually had to go and download it and build it from source so that I could get it working again. I'm like, this is not what I expected of you, Go. What happened? And maybe it's just a mistake on the part of the people who packaged the system. But I had never experienced this before, so it obviously can happen. And then actually I ran LDD on a few binaries that are Go, and I realized they are actually dynamically linking with some things. So it's more like the same as Rust in this instance. So maybe Rust and Go are equivalent in this space, which is great if there are choices.
Interesting. Yeah. Kind of, reflecting back on what you were saying about the borrow checker and how it works and how it's sort of safeguarding things for you. I really felt, and I don't like this, but this is on me. When I was working in Rust, I have distinct memories of like feeling like I was just driving down the street, bouncing off the guardrails. Because I didn't really fully understand what was going on, and I was just basically just being empirical and experimental with the compiler to try to figure out like what the language was trying to do and what I was trying to tell the compiler to do.
This is like the sort of like the C programmers, someone who's new to C programming. Putting ampersands and stars in until they get the value out from the pointer or not pointer, or did you need a pointer to a pointer? I don't understand it. Star. No, that didn't compile.
Yes,
kind of feel for it. Like, do I need to make a ref of this? Do I need to box or unbox it? Which of these magical things do I need to do to make it get to the next thing? And what did I really say by saying that? Yeah. Is that not true of most languages, though?
Well, I mean, it can be true in any language, but anytime I'm in that state, it just feels icky. Right? Like I feel like I'm literally making it up as I go along, which is not the kind of thing that I want to do. And so it was hard for me, and maybe this is because more about not Rust in particular, but just the sort of programming style. Because like I said, I had done some Scala before, but I kind of got a little bit of that vibe in Scala too, not nearly as bad. So it's maybe just like that programming style in my brain just don't fit, or maybe I just haven't done enough of it. I don't know what. But it just sort of like, I really don't like a world where I'm like, all right, I wrote a bunch of code. Let's see what happens, right? Like, there's always a little bit of that. There's always like, I'm not going to make the assumption that I did this right, but I at least want to have some level of confidence that like I'm attempting to do the thing that I'm trying to do, and I'm not just basically just voodoo chicken coding where I'm just like, I don't know.
Programming by coincidence. Like,
yeah, right.
In fairness, though, yeah, I think there is a little of that in anything you do. And if you were in the middle of a novel code base as well, it's exacerbated by the fact that you not only didn't know the language, you didn't know that maybe someone had made a call that wasn't necessarily the right call about how something should be done, and then you were suffering the consequences of it. You get to that point where you can have a strong opinion about, like, this is just being done wrong, and that's why I can't do this thing that should be obvious.
Right.
So maybe a bit of that in there. Plus, I think there's just that mastery feeling, and if you've been working in languages for a while that you feel you've mastered, if you can bang out 20 lines of code and know that it will compile and run and be probably right, that's you'd realize you're in that sort of that level of expertise, and then it's kind of difficult to go back and very frustrating to be in a situation where you aren't able to just do that.
Yeah.
So maybe a bit of that. Anyway, but
yeah, overall, I mean, I loved Cargo. I love the ecosystem. I love the theory behind the language. I haven't found a problem yet where I'm like, the right answer to this is Rust. But as you were pointing out about Go, maybe that's the language I should be thinking about when I do
next time you want a little command line thing.
I need something command line. Let's maybe
just need to like copy somewhere and have it work and run on like a bunch of computers. It's not. You could go far wrong.
Right.
So who do we know who is using Rust? Because famously Mozilla have sort of backed away from it, and the Rust Foundation was born separate from Mozilla to sort of carry on the torch of the language. The only people I know of that are seriously involved in Rust are some acquaintances and pals at Amazon, who Amazon picked up quite a number of the Rust core team after the Mozilla announcement that they were not continuing with it. And I mean, to me, that makes some level of sense. I mean, Amazon want to hedge their bets for also a lot of different use cases, and so one of the many languages they support or could support is Rust, and so maybe they're looking in that particular direction. I don't know, but who else is using Rust? But everyone knows someone who wants to use it, and it's like, oh, for my next project I might use Rust, but no one I know is actually writing it that much.
I'm googling something real quick because I remember from when I was looking at this more deeply, there was a guy that was way into Rust for embedded software.
Oh, neat.
And I'm trying to remember this person's name, and Google is failing me here. But that was an area that I thought, like he had gotten the Rust compiler working on these like little ARM chips, and oh god, I really want to like track this guy down. Maybe I'll see it. Maybe if I can find this, and I'll just put it in the show notes.
Put it in the show notes if we find it. Yeah.
Yeah. But it was really interesting, and this was definitely this was like the classic example of like, wow, this is a solution that I really wish I had a problem for.
Right.
Because this stuff looks so interesting, but it's just like I don't know how I would use. I got
a drawer full of things that look like that. Just write down here various things. Like, oh, this would be cool, and then never got anywhere with it.
Yeah. So I will. I'll track that down and put it in the show notes. But there was a guy, one person in particular, who was just like very committed to this and like trying to put it on as many
embedded systems and like tiny systems, because it's a native thing. It has no runtime. It's kind of sweet spot for this kind of thing.
Right, and the guarantees that it provides. I mean, nothing's more terrifying to me than the idea of. I mean. Blockchain smart contracts also have this property, and they are equally terrifying, where it's like, I'm going to write this code, and I'm going to put it out in the world, and there's no take-backsies, right? Like, this is it. This is it. It's going to be out there, and it's just got to be right.
Yeah, that's an interesting one, yes.
Rust has, a lot of. I'll be a lot more patient with the slow compiler if I'm in that situation.
If you're like writing an embedded system for a brake microcontroller in a car or something, but that's different. I mean, they were those folks were already in the world of like writing MISRA C, which is like a subset of things in C. So maybe Rust could take over from there. But I guess actually we're talking of things that are using it that we know of. Obviously, then you mentioned blockchain type stuff. So the Ethereum node that you were writing and modifying was obviously Rust. Is there other aspects of in the crypto world, perhaps, or is it got more traction in crypto than somewhere else?
Not that I am aware of. I'm trying to remember the name of that Ethereum node. Parity? Parity is the name of the Ethereum node.
And Parity, Parity.
Parity, yes.
Not parity,
right.
as in like a parrot.
Right. Parrot.
Or parody like Weird Al Yankovic.
Right. Oh, yeah.
You Americans and your unclear diction.
You want some water?
Oh!
Why'd you leave the D out of water? Yeah, looking at Parity might not be alive anymore. I'm sort of looking at this
but
GitHub
it was
repo.
A project that was around at least at some point in Rust. That's cool.
Absolutely. So yeah, I don't know if there's other places in the crypto world that uses it.
But Rust sort of has always the bridesmaid, never the bride kind of feel to it. Everyone wants to. It's the language you want to kind of look at next. But if we just get that one cool problem that will fit it, and we haven't quite got there yet, except for like a little log parser in my case, and some now defunct Ethereum node
blockchain software. Yes, exactly.
Well, before we further show up our ignorance really as to the current state of Rust, maybe we should leave it there with that.
Yeah, this is when I'm hoping we get a lot of Twitter responses and people being like, "Oh, it's used here, it's used here."
Yeah, that would be cool. I mean, maybe that would push us over the edge as well of of using it ourselves in our day job, because I think that's where it really starts to matter, isn't it? It's where someone will pay you to do that work is when something becomes worth talking about. At least, obviously, learning it for your own sake is also very much worthwhile. I mean, I was writing JavaScript long before someone was paying me to write JavaScript, but it definitely helps justify the investment of time to learn something if it's your primary or a primary responsibility.
Yeah, I mean, because then you get to do it every day, right? And it's like
how you get better at something. Cool. Well,
all right. You want to call it there?
Let's call it there. All right. Until next time, my friend.
Until next time.
You've been listening to Two's Complement, a programming podcast by Ben Rady and Matt Godbolt. Find the show transcript and notes at twoscomplement.org. Contact us on Twitter at 2CP, that's at TWOSCP.
Theme music by Inverse Phase, inversephase.com.